Hi everyone. What we're going to be doing today is taking a real kind of quick review of a major topic from last year. And we're going to be on pages 4 and 5 of the lecture outline called Chemical Reactions Lecture. And we're going to be talking about the classes of chemical reactions. Okay? Now we spent an entire hour lecture making a lot of jokes last year about dancing and couples coming together and breaking up and catching on fire and things like that. So I'm hoping that you actually have some good notes from that and you're remembering it. Combination or synthesis reactions are basically things coming together. A plus B forms AB. These don't just have to be elements. These can be compounds. It can be complex. It can be simple. Okay. We have this example of metal oxides reacting with water to form bases. Metal oxides are things like Na2O reacting with H2O to form NaOH. Yes, you have to get all of the ratios right. You have to balance them correctly. Okay. All the stuff from last year I expect you to remember for this year. Okay. Now, think about this. What's the opposite of a metal? It's a nonmetal. What's the opposite of a base? It's an acid. So nonmetal oxides can hook up with water to form acids. We just happen to call them ternary acids, which means they have 3 elements in them. Okay? Now, oxygen can react with almost anything, and in some cases including itself. Okay? So, I don't know, I think I'll choose phosphorus. 4 P's plus 5 O2s to form P4 O10. There are a lot of different possibilities for oxides. And metals can combine with nonmetals to form ionic compounds. We always seem to use Na plus Cl2 gives us NaCl2 and 2. Okay. Decompositions, that's divorce, breakup. Usually caused by heating or another driving force like maybe electricity. Okay, carbonates, like calcium carbonate when heated, will break down to form metal oxides like CaO and carbon dioxide. So carbon dioxide always comes out of carbonates. Metallic hydroxides like calcium hydroxide, when heated, decompose into metallic oxides like CaO plus H2O. But you already knew that because that's the same reaction that's up here. Okay? Metallic chlorates like KClO3, which back in the early 60s we considered sending into space in the Mercury, Gemini, and Apollo programs, is a source of oxygen because when it decomposes, it can form KCl and O2 with a 2 there, a 2 there, and a 3 there. You get oxygen off of chlorates. Acids, when they decompose, can form nonmetallic oxides in water, which would be the opposite of this right up there. Okay, so something like H2CO3 in a soda can give you H2O and CO2. That's where the carbonation comes from. Oxides can be heated to decompose. I did this when I was in high school chemistry. They don't let us do anything like this now. We heated mercury oxide to make mercury and oxygen. Okay? Now, some decomposition reactions can be produced by electricity. We call this electrolysis. We can run an electric current through water, and we can make hydrogen and oxygen gas. And you probably remember me actually doing that with an electrolysis device last year. Ammonium salts, like, well, let's say ammonium bromide this time. Okay, can break down, and the ammonium bromide will give you NH3 and HBr. Okay, you got this handout last year as a class handout. Probably slightly different examples on it. I don't always use the exact same examples, but close enough. Single replacement. I probably talked about some volleyball player walking down the beach and breaking in on a couple, something along those lines. Guy replaces guy in a couple, or girl replaces girl in a couple. And we pretty often use the joke that chemistry isn't tolerant. The metals only replace metals, and the non-metals only replace non-metals. So an active metal can replace hydrogen in water. It's got to be really active, like sodium, like, group 1 or group 2. Plus HOH, the way I like to think of water, to produce NaOH and H2. We need a 2 there, a 2 there, and a 2 there. And this is the hydrogen right there that gets kicked out. And OH is the negative ion. Hydrogen is one of those things that's always going to be diatomic when it's alone. H2O2, F2, Br2, I2, N2, Cl2. We used to jokingly call that Hofbrinkel. Now, a metal may replace hydrogen in an acid. So if you have something like zinc plus HCl, you can get H2 and ZnCl2. Throw a 2 in front of that. When you have a metal that is more active than another metal, it can kick that other metal out, zinc plus CuSO4, to give you ZnSO4 plus Cu. In fact, that's going to be your lab for this weekend. Okay? Then a halogen can replace a halogen that is below it in the periodic table. And what I'm hoping you've now realized is what we are doing is we are establishing the concept here of an activity series. Okay. Now, time to move on to the double replacement reactions. Switch partners. It's like a squared ounce. So an acid and a base can react. So NaOH can react with HCl. NaOH, very typical base. HCl, very typical acid. Forms water, and NaCl, very typical salt. A precipitation reaction, which we'll be doing a lot of this week. So in a precipitation reaction, we can start off with AgNO3 plus NaCl, and we can get AgCl and NaNO3. AgCl would be that precipitate. A metal oxide can react with an acid. Metal oxide, let's use calcium oxide. And HCl, first choice acid for everything, would form H2O and CaCl2, so I'm going to need to put a 2 there, and that's balanced with just that. Now sometimes we can get much more complicated. Calcium hydroxide plus ammonium sulfate will react to form calcium sulfate plus ammonias plus waters, and there's going to be a 2 on the ammonias. Okay? let's just check. 2 times 4 is 8, 9 and 10. 2 times 3 is 6, 7, 8. So I'm going to need a 2 there. Let's check the oxygens. 2 plus 4, 4 plus 2. There we go. Okay. Now, combustion. Combustion is burning, okay? Combustion is anything reacting with oxygen. It doesn't just have to be a hydrocarbon. And often in first-year chemistry classes, teachers will say hydrocarbons. Those things that contain carbon and hydrogen react with oxygen to produce CO2 and H2O. That is not wrong, but those are not the only things that burn. Metals burn. Non-metals burn, okay? They always form oxides, okay? So a hydrocarbon like CH4 can react with O2 and can form CO2 and H2O, but a metal like magnesium can react with O2 and form MgO. Put a 2 there, put a 2 there. Nonmetals can combust to give oxides, like sulfur. Can react with oxygen and give us SO2. Okay. So there you go. That's just a short, brief little review of the types of reactions that I just wanted to make sure that you had reference to in this lecture outline. Okay, this is Morgan signing off.